So if you want to, you can now join me in a kind of sing-along song coding adventure where you use the same project that I use and code all the stuff with me. But if you're fine with just watching me, that's also fine for me. You can find a link to the starting point of the project and to the finished point of the project in the description below. All right, so in order to understand what's going on, let's have a look at how this works in Unity. Now, I've prepared a little project which I call Beauty Lies in the Eye of the Beholder. And for those of you not familiar with D&D, this is a beholder, and it's like an evil, lawful monster, and it's got 11 eyes, so it's kind of like a gentleman thief, like in Ocean's 11, right? And the goal is you can grab these 3 pieces of art, and then comes a boss, and you have to fight it with a laser beam that should spawn from your eye. However, this is currently not implemented, and we're going to do this right now. So in order to test this, let's move this guy a little bit upwards here, and let's look at the code. Now here I already have some stuff in here that's not really that important. It's just a movement and that he dies when he touches the boss. But what's going to be interesting is how we can create an eye beam that moves downward. So it should move from this eye just downward and deal damage to everything it touches, for example. Now, the first thing we need to do is we need to create a Raycast, and let's look how we can do this. I can say physics 2D dot Raycast. And this is already the method that we're going to use. And before we use it, we first look at how it works. It returns a class Raycast hit 2D, and it needs an origin vector and a direction vector. And if you remember our drawing from earlier, I pimped it up a little bit. We have here this origin and the direction. And the origin will probably be the eye of the beholder. The direction needs to be downward. So 0, 1, 0. So let's just do this. Let's Raycast. And we start with the origin. This is the position of the beholder itself. The direction will be vector 3 dot down. So this is, you can see here, 0, minus 1, 0. Sorry, I said 1, of course, minus 1, so it goes downwards. Right. Now, let's try this out. Now, we create the Raycast, but we don't save the information that the Raycast generates yet. This information is saved in this Raycast hit 2D. And I think it's a struct. We can look at it. Yeah, it's a struct, but if you're not familiar with structs, just imagine it's a class. It's not that different. So we create a Raycast hit 2D, and I call it RayHit. And in this, we save all that we need. Now, let's just debug.log some of the stuff that's in this RayHit. Now, I just type it, say dot, and it immediately tells me the information that I can get out of this Raycast. Now, the first thing that's very important is the collider. So I know with which collider the Raycast collided, so which collider it hit. The second thing is the distance, that you can use it sometimes. And another thing that's very important is the point. The point tells us exactly the position where the Raycast hit another object. And that's what we're going to print out just now. And if I go back in here and hit play, and I try it, you can see it already prints different positions. And there's a little problem with that, but we're going to look at it later. So I can already kind of debug it, but it's not a very good kind of a message that I get from debugging. So Unity provides you with something a little bit better to debug it. So we can say debug.drawLine, and this draw line also requires a start and an end position. And the start position will again be transform.position. And the line should be drawn onto the point where it hits something. And then we can also say that it's color.red. And now if we try it, we should see a red line, but it's only visible in the scene. So if I shoot now, nothing happens. And this is due to the fact that our Raycast hits every collider, okay? Now, if we start the Raycast in here, you can already see, I mean, maybe you can't see, but there's a collider on the beholder itself. So it will immediately collide with itself. And that's a problem, of course, because we don't want it to collide with itself, but we want to collide it with this wall down here, for example. So in order to fix this, we can create a layer mask that does collide with everything except for the player. And the player already has his own layer here. So these are those physics layers. And so the thing we need to do is we have an iBeam layer mask. I already prepared it as a public variable. And we want it to collide with the default and maybe with the enemy mask. So let's go back into the code. And now let's look at how we can manipulate this Raycast to also use this layer mask. So we look at the different implementations, and here we can see origin as first parameter, direction as second, then a distance, how far we want to shoot the Raycast, and lastly, a layer mask that determines which physics layers are hit by it. And this is the implementation that we're going to use for the Raycast. So we already have the first two. Then for the distance, let's just say 100 meters. And the layer mask, we will use this public layer mask that I already just set. So let's use this iBeam layer mask. And that way, it shouldn't collide with the beholder itself, but rather with the things except for the beholder. So let's try it again. If I move around, press left, look at the scene view here. You can now see if I press the left button, it shoots this laser beam. However, this is just to debug stuff. You can also see it collides with down here. The collider isn't set perfectly. You can see it overlaps a little bit. So it works actually, but it's not visible in the game view. Remember, this is just debug.drawLine. This is only visible in the editor. This won't help us at all to show this to the players. In order to do that, we're going to need to make things a little bit more complicated. So in Unity, there's a rather simple way to draw a line for the players to see. And that is by using a LineRenderer. And I've prepared one here. I just need to activate it. And you can immediately see it draws a red line. Now, if I want to change where this line lies, it has two positions. And the one is the start position. That's set here. So if I press here, for example, 1 or 2, it changes where the ray starts. And the Y position, of course, works just like this. So I can move the positions around in order to change where it is. And luckily, I already know the start position and the end position where the line should be drawn. So I can set these things via code. So let's disable, or let's just enable it for now. We're going to implement this later. Now, let's get back into the code. I already have a public variable for the LineRenderer, and if it's not already done, one can drag it in here so we have a reference to that. Okay, so we now know this LineRenderer variable is filled. And I'll for now still leave this draw line debug message, but I also use the LineRenderer and set the positions, or let's make it the easy way first. We set the position, the starting position with the index 0. We set it to transform.position. And then the end position, which is the position at the index 1, will be set to rayHit.point. Now let's save this, go back into Unity. And this needs to be activated, otherwise I can't see anything. And if I play now, actually nothing happens because I need to press the left key, and now you can see it works. However, if I release the key, the line won't disappear. So that's something we should also fix because it's kind of weird if that's not working. So in order to do that, we can just say up here where we update the mouse button, we can also say that the LineRenderer should only be enabled if the mouse button is down. So we can set it to input.getMouseButton 0. So this returns true while the mouse button is down and false while the mouse button is up. So that way it should be disabled if if I release the button. So I haven't pressed the button. Now I click it and you can see it shows up. I release it and it's gone. Okay, so that's already quite nice. However, we might find some issues in other games if we do it like this. Let me demonstrate what I mean. Let's just move this wall a little bit out of the way. And you can see everything works fine as long as I'm hitting something. But it could be the case that I'm not hitting anything. Then something very strange happens. So as long as I'm hitting something, the eye shoots down like we programmed it. And once I hit nothing, suddenly the direction jumps somewhere here. And it's always to this position. And to give you a little hint what's going on here, this is the position 0, 0, 0. So you can maybe already imagine what's happening here. The ray doesn't hit anything. And because it doesn't hit anything, it just says that the collision happens at 0, 0, 0. And that's a strange behavior that we don't want to happen. So we should try to fix this by creating an if statement that checks if it is hitting anything. So we only want to do this stuff if something is hit. So I can remove this draw line now, and we can just ask if rayHit.collider is not null. So we only set this, we only fire the laser right now if we hit something. Otherwise, if we don't hit anything, we want to do it a little bit differently. We would like to just move the ray downward for quite far. So let's say I copy this here also. So we say from transform.position, we want to just shoot it down. So we add vector3.down times 100. So we shoot it down for 100 meters. And now it should also work if we don't hit anything. And let's try it out. So you can see if I don't hit anything, it shoots down quite far. If I hit something, it hits it. So that's already the behavior that we're going to need. Now we can also make things a little bit more beautiful in the code side, because we have here duplicate code, and that's always bad. So let's move this up here so it is executed in any way, no matter if we hit something or not, and we can remove it here. So that way the code becomes much tighter and thus I think a little bit easier to read. Well, now the next thing that we may want to address is we want probably to kill the enemy if we hit him. So you can see I can hit him all I want. Nothing will ever happen because I didn't program that this does any damage. So the next thing that we might want to do is that if we hit something, we just check if the ray hit dot collider dot tag equals enemy. So if we hit an enemy, and of course our enemy prefab has this tag. So if we look at the enemy, who I called Mr. Fancy Pants, he has the enemy tag. So if we hit an enemy, we say ray hit dot collider dot get component, and we're going to get the Fancy Pants script from him. So this is the enemy. And we're going to say enemy dot HP minus equals, let's say we do 10 damage per second, so, or maybe even 20 times time dot delta time, because this is called every frame. So we need to adjust it so it does the same damage no matter if you run it with 60 FPS or with 15 FPS. So the HP of the enemy should be reduced now, and once he has 0 HP, he should die. Now let's try it if that works. I collect the precious art. He spawns, and if I shoot him long enough, he should die. And it worked. So I hope you enjoyed the lesson and are now able to use Raycasts on your own.